Okay, we're going to go into section 2.2b, and we're going to be talking about normal distributions and how to use a table A. How to use table A right here. And so here we go. We're going to talk about how can you apply normal distributions. Well, let's take this example of check your understanding. When a professional golfer, Jordan Spieth, hits his drive, he's an older professional golfer, the distance ball travels can be modeled by the normal distribution with a mean of 307 and a standard deviation, all right, of 8 yards. On a specific hole, Jordan would need to hit a ball at least 290 yards to have a clear second shot that avoids a large group of trees. What percent of Jordan Spieth's drives travel at least, all right, 290 yards, okay, 290 yards. Okay, so if we're looking at this right here, I'm going to first just draw this out since all of his drives are normally distributed. We'll have this. We're going to have our mean, which is 304, all right, followed by a standard deviation of 8. Now, I'm going to label this right here as 304 yards. And so in order to figure this out, we're going to standardize it. We're going to use a normal distribution. We're going to use a z-score to help us figure this out. And to help us figure this out, we're going to figure our percent, all right, our percent. And so from this, we're looking for 290 yards. Well, 290 yards is on the left side of 308, which is his mean. And so I'm going to put 290 right here. Now, it says they have to travel at least 290 yards. Now, what does that mean? That means you can have any values that are greater than that, right, located right there. So we're looking for what is the percentage of this shaded area, okay? Now, to help us figure this out, we're going to use a z-score in table A. So we're going to take and find the z-score of this one, all right, 290. So to do that, we're going to take 290. We're going to subtract that from 304, which is the mean, divided by the standard deviation, which we know is 8. Now, when you put this in your calculator, 290, all right, minus 304, all right, and then divided by 8, you get a z-score of negative 1.75. Now, if you recall, we're going to look at this little chart here, and we're going to look for negative 1.7, and we're going to go all the way over here where it says 5, okay? And we have that one. What you can see then is going to be 0.0401. Now, what did that give us? That actually gives us the percentile. Okay, that gives us a percentile. And so what we have here is that with this percentile, okay, if I redrew this right there, I use my normal distribution and I transform everything into a normal distribution. I have 0 right here. We're going to have this negative 1.75 here. And what we found with this percentage, all right, is this area over here, which is going to equal, all right, and this is probably should be scooted over a little bit more, 0.04, all right, or if you want to say, all right, that's the density curve, or we could look at it as 4.01% of the data. And the same thing right here, this is the same thing, it's going to be 4.01% of the data, okay? But that's not what we're looking for. We're actually looking for what is when it's going to be at least 290 yards. And so we're actually looking for that red portion. So to figure out that red portion, okay, is we're looking for the percent. We're going to be taking this and looking at that by taking 1 minus, all right, 0.0401. And if you do that, we get 0.9599, which is then 95.99%. All right, so what percent do they have it? 95.99%. That is going to be our answer. Cool. All right, so that's how we can use what we have with our normal distribution. all right, and use a table A and using z-scores to help us figure that out. We can also use this to answer this question. On another golf hole, Spieth has the opportunity to drive the ball into the green if he hits the ball a distance in the top 10% of all his drives. How far does this ball have to go? All right, so what we have right here is we're looking for the top 10% of all of his drives. And once again, we have 8, but we're given is that we really want to have 10%. So we're looking for this top 10%, so we have a value of 0.1. And so right here, how do we figure this out? Well, we're given actually a percent. And so if we look over here, we have to try to figure out, okay, where does it say 0.10, 0.10. And when you're looking through all of this, all right, where is going to be the closest one to 0.10? 0.10, probably right there, all right, 0.10, okay, of that value. Oh, or actually, these are percentiles. So actually what we're looking for, I apologize if those of you are wondering a little confused. All right, so when we look at a z-score, we're actually looking at, all right, 0.9. And since these are symmetric, we could probably use this in the opposite side, but we want to know 0.9. So 0.9, all right, so we're looking for 0.9, and roughly about right there. Okay, ish. Okay, that's approximately, that's the lowest value we got. And if you look at this, it's going to be 1.300. Okay, so our z-score at 0.9, all right, is going to be 1.3. Okay, and that will give me the 0.9 that I'm looking for the percent, or the percentile. Now, once I figure that out, I know that my z-score is actually whatever the value I'm looking for, because really that's the value I'm looking for, is what is this x value. So we're going to take that minus our mean, which is 304, and then divide that by our standard deviation, which is 8. Now, doing a little algebra, we can take 1.3 times 8, and then we're going to add 304 to that, and what we get is a value then, x value of 314.4, and what is it going to be? This is yards. And that, my friends, is how we can use z-score to help us find a value, all right, in our distribution. Okay, so with that, I hope this helps you out in identifying these different things. Yeah, so good luck and God bless in the rest of your problems.